Hi everyone, welcome back to Data Cadence. My name is Rahul and I work as a senior applied research scientist. And in this particular video, we are going to talk about one of the most important algorithms for generating the word embeddings that came out in 2013, that is Word2Vec. And in Word2Vec, often you have two types of models. The first one is a CBOW or continuous bag of words, and the other type of model is a Skipgram. Now it's very important to understand the difference between these two because each of these have its own pros and cons. And again, that's a decision that you have to make as a data scientist when you're trying to use Word2Vec to compute the word embeddings. And now we do have relatively newer models like sentence transformers that are much better at computing the word embeddings using something called as self-attention. And again, that could be the topic for another video where we can talk about transformers and how they work in detail. But I think it's really important to understand how does Word2Vec work, because this particular method had dominated the word embedding space for quite some while, right from when it came in 2013 and up till the point when the Transformers paper had come out, I guess in 2018. So without further ado, let's begin. So Word2Vec, like I mentioned, is one of the popular techniques for learning word embeddings from a large corpus of text, and it was introduced in 2013 by Mikolov and his team from Google. And basically there are two main models like we mentioned for Word2Vec. The first one is a CBOW and the second one is a Skipgram, and we will talk about both of them in detail, try to understand what does each of these models do and what are some of the main differences between the two. And this is also an important interview question because it tests your understanding as a data scientist, how in depth you know about some of these concepts and what are some of the things that you need to consider in a realistic setting when you're trying to apply one of these models to generate word embeddings. So first let's talk about CBOW or continuous bag of words. So first let's talk about what is the main thing that you are trying to achieve here. So you are trying to predict the target word based on the context words or the surrounding words. So say you have a sentence, for example, say the house cat sat on the mat. So if you have a context window size of 2, CBOW might use the words the, house, sat and on to predict the word cat, because if you have a look at two words prior to cat, it's the and house, and two words after the word cat, it's sat and on. So the training process is pretty simple. For input, you do have a one hot encoded vector of your context words, and you have a projection layer in the second step. That is, the input vectors are often averaged to form the context words or the context vector, and then in the third layer you do have the output layer. The context vector that you compute in the second step is passed through a softmax to predict the probability distribution of your target word. And the objective of this particular training exercise is to maximize the probability of your target word given your context words, right? Now there are certain advantages of the CBOW method. That is, the first one is it's very efficient. CBOW tends to be really faster when compared to Skipgram. We will talk about Skipgram subsequently, but CBOW tends to be significantly faster than Skipgram because it simply averages over the context words, which can lead to a faster convergence, and therefore CBOW is very much efficient when you want to use it with large data sets, right? The second advantage is it is very much better for frequent words. So since CBOW uses the average of your context words or your surrounding words to predict the target, therefore it often leads to a better representation for the words that are appearing more frequently in your corpus, and that makes it a better choice for high frequency words in your corpus, right? There are certain disadvantages of CBOW. So it is less accurate for rare words. So like we mentioned, it relies on the surrounding words average. This can dilute information for the rare words, and therefore it can lead to a suboptimal performance for the rare words. And the use cases might be suitable for tasks where the context words are reliable and frequent, such as a large and a well-balanced corpora of text. Next, let's talk about the Skipgram. So Skipgram does the opposite of CBOW. That is, it tries to predict the context words given a target word, and it's a reverse to CBOW. So for example, if you have the same statement, say the house cat sat on the mat. So using the word cat and a context window size of 2, Skipgram would typically try to predict words in the surrounding context. That is, words like the, house, sat and on. And this is exactly reverse of what we discussed in the CBOW. And the training process for Skipgram is as follows. So you start with your input layer as your one hot encoded vector for the target word. Now your input becomes your target word, and what you're trying to predict are the context words. And in the projection layer, the input vector is passed through an embedding layer, which you learned during the training phase. And this is what is the representation of your word. And this embedding layer is used to basically, the input vector is passed through this particular embedding layer to obtain the word vector. And the output layer, basically you have the word vector that is used to predict the probability distribution of your context words through a softmax layer. And the objective here is to maximize the probability of your context words given your target word. Now let's talk about some of the advantages of a skipgram model. So skipgram is better for rare words. So it's the opposite of CBOW. It treats each of the surrounding word as a separate classification problem. Therefore, it preserves more information and therefore it is more efficient for rare words. And it often produces higher quality embeddings when compared to CBOW. So yes, it does produce high quality embeddings and it tries to capture more nuanced relationships between your words, right? There are certain disadvantages to the skipgram approach as well. The first one would be a slower training. So since skipgram basically predicts multiple context words for each of your target word, it can lead to more number of computations and therefore you will have a slower training time. And again, based on the above point also, you can say that skipgram is much more computationally intensive when compared to your continuous bag of words. And the use cases for Skipgram is it is very much suitable for tasks where you are capturing the relationship of rare words is very much crucial, such as if you work in a specialized domain which has its own unique vocabulary, then in that case Skipgram would be a much better choice compared to CBOW. And in an interview setting, if someone wants to ask you, or not only in an interview setting, even if in a realistic scenario you want to choose between which one should you go for, whether a CBOW or a skipgram, so these are some of the aspects on which you can decide which one should you go for. So yes, these are some of the key differences and you can talk about these points. So the first one is the objective. I'm just quickly recapping what we had seen above. So the objective for CBOW is to predict the target word given your context words. For skipgram, it is to predict the context words given your target word. The second one is the training efficiency. Of course, CBOW trains faster and it's more efficient compared to skipgram. Skipgram has a slower training and it's more computationally intensive. The third point that you can talk about is the performance on the rare words. So CBOW may struggle with rare words. Skipgram, on the other hand, performs better at capturing relationships for the rare words. The fourth one is the quality of embeddings. So CBOW, like we mentioned, produces more stable embeddings for the frequent words, whereas Skipgram produces more higher quality embeddings and captures more nuanced relationships in your text corpora. Let's talk about some of the common aspects for both CBOW and Skipgram. So both of them use certain techniques to make the training process more efficient, and some of those techniques are negative sampling and hierarchical softmax. So both CBOW and Skipgram use these particular techniques to make the training more efficient. And the idea behind negative sampling is pretty simple. Instead of updating the weights for all the words in your vocabulary, can you update the weights for a small sample of negative examples? That's the core idea behind negative sampling. And hierarchical softmax, on the other hand, is a binary tree representation of your output layer to reduce computations. So this is more like a software engineering hack, and a lot of the beautiful software engineering based optimization using a lot of efficient data structures is applied in the hierarchical softmax to make the training process more efficient. And again, this hierarchical softmax is also used both across CBOW and Skipgram to make the training process better. And then let's talk about some of the hyperparameters. So if you talk about the first hyperparameter, that would be the window size. It's a very crucial hyperparameter for both the models. A larger window size would allow you to capture more broader context, but it can also dilute specific relationships between your different words in your corpora. And a smaller window size would often capture more specific relationships, but again, on the other hand, it may miss out on the broader context. The second hyperparameter would be the embedding dimensions. So higher embedding dimensions capture more information, but can also lead to overfitting and increased computational costs. So these are some of the common aspects that we had a look at when it comes to both CBOW and Skipgram. So if I were to summarize, both CBOW and Skipgrams are powerful models for learning the word embeddings, and each of them has its own strengths and weaknesses. CBOW being more efficient and stable for frequent words and making it suitable for a large scale corpora. When your dataset is really large, you might want to prefer CBOW. But on the other hand, Skipgram excels at capturing the detailed relationships, particularly for the rare words. And although it comes at a cost of increased computational complexity, but it also gives you higher quality embeddings. And understanding these models and the differences between them helps a data scientist choose between the appropriate method based on the specific needs and the characteristics of their particular data sets and the problem at hand. So hopefully this video gave you a lot of insights on how do each of these techniques work, what are some of the pros and cons of each of these techniques, and which one you would want to prefer depending on different scenarios and different conditions that you might be operating on. So hopefully this gave you a good understanding and will also help you answer this very common interview question where they ask you the difference between the two. And if it did, please consider liking this particular video and subscribe to this channel for more such content, because I do plan on uploading more such videos around a lot of these topics. So thank you so much for sticking till the end. Till then, take care, bye bye, and see you next time.